IVM.
Hi, I'm Rohan Joshi, and on my podcast, the show about crypto, I've been having some pretty cool conversations with industry experts about what exactly cryptocurrency is and what makes it so exciting. If you haven't already, please check it out on the IVM Podcasts Network. Now, a quick shout out to my fellow crypto heads. We've got a listener survey going on, which will take not more than 10 minutes of your time to fill out. So please check the link in the description and help me out by filling it up. Don't forget to tune into a show about crypto on the IVM app and wherever you get your podcasts from.
Hello and welcome to Simblified. On today's episode, oh, by the way, this is just me, Chuck, doing a little intro before we get into the episode itself. So, hi. Today's episode, we are doing an interview with two folks who work in the space of artificial intelligence. One is a friend, one is a listener who wrote into us saying that if we ever do an episode on AI, they'd love to be a part of it. So we just put everything together and we have done one mega episode, which we're splitting up across two episodes. And I think you are going to love these. We touch upon so many aspects, the basics of AI, how AI is different from other buzzwords like machine learning, deep learning and all that, the evolution of AI, the application of AI in our lives, the ethical implications of AI. We obviously go off into all kinds of different tangents, and the signal to noise ratio in these two episodes is quite high, as you can imagine, which normally is the case when we on Simplified get people who are smarter than us onto the show. This is part one of the two-part interview that we are doing, and we hope you enjoy it. Kartik and Shivam are our guests, and we will take it away right after this.
Do you wonder why China does the things that it does? Or want to know how we could improve online privacy? Or perhaps you're thinking about how we can kickstart India's economy. If you'd like to search for the answers to such questions, check out All Things Policy, a daily public policy podcast that covers everything from employment figures to aircraft carriers. Tune in from Monday to Friday for new episodes and fresh takes.
Hello and welcome to another episode of Simplified, the podcast where your hosts try to make sense of the world, mostly using Wikipedia research and failing that, relying on Naren's memory of P.G. Woodhouse and Yes Minister quotes.
And general historical events. And through the passage of his life.
Like Naren was around when Pangea happened.
Yeah.
So once in a while, when we don't have anything much to talk about, we get on people who are way smarter than us, a very, very low bar to clear, to be very frank. And today is one such episode where, one of the things that I've been wanting to talk about for a very long time is this newfangled technology called artificial intelligence, which doesn't seem to be going away and just keeps coming into every aspect of our life. So we thought, okay, let's get a couple of experts and let's talk, let's demystify what this thing means. So we have not one, but for the first time on Simplified, we have two different guests from two completely different, they don't know each other types. We've had two guests before, but they've come from like the same place and all that. So this is going to be fun. So consider this sort of like a panel discussion of sorts, but the panelists two and the people are dumb people asking the questions are actually three. Yeah, let's kick things off. Also, okay, we haven't introduced the panel hosts properly as always. 250 episodes and we're still bumbling over that. You know us by now. There's Naren, there is Shriket. Shriket, say hi. And there is me, Chuck. Tony, unfortunately, will not be able to join us today. Don't worry, he is not unwell. It is just work issues because of which he is unable to make it.
Hey man, if everybody else is unwell, someone has to work.
Yeah, that's true. That's true. Okay, so enough of us rambling on and on. We've got a panel that we have is, we've got Kartik, who's a friend of ours for a while now. And there's Shivam, who's actually a listener who had written into me on Instagram saying that, hey, if you guys ever do an episode on AI, I would love to contribute. And I thought, hey, this is perfect. So let's just, get everyone in the mix together and see what happens. So that's what we have over here, Kartik and Shivam. Welcome to Simplified. Thanks for making the time, especially since it's so late where you guys are.
Thank you, everyone.
Hey guys.
And okay, I think we should just start off with you guys telling us who you are, what you do, and yeah.
Yeah, take it away. Shivam, you want to go first?
Sure. Hey, I'm Shivam Tundele, and I've been in USA since 2014. Just like every other Indian, I came here for schools and studies. I did masters in ID, and then most of my work here has been in AI and data science. So after my masters, I joined Tata Consultancy Services North America in their retail domain, and I worked for JCPenney, Walmart, and Hallmark cards. Then I left TCS North America, and then I joined Cerner, which is a multinational healthcare IT company. So I have also experience in healthcare, AI, and machine learning. And right now I'm working at Nordstrom. I'm not sure if you guys know Nordstrom, but it's luxury upscale fashion retail company. And hopefully I'll be moving to Seattle soon because of Nordstrom.
That is very cool. And I see a nice collection of guitars behind you as well. Kartik, those will work well for you in Seattle, by the way, the guitars. I'm not quite sure whether Kansas City has much of a metal scene, but Seattle, I think you will be able to use us and take forward the legacy of Kurt Cobain, Eddie Vedder, and Alice in Chains.
You will be contributing to keeping people sleepless in Seattle. So that will be good.
Oh man!
Did not expect that. Did not expect that. Did not expect that.
Yeah. I have a son who does that to me, man.
Excellent.
Wow.
Kartik, take it away.
All right. Hey guys. So I'm Kartik Talamadupula. I am a research scientist for IBM Research. I did my bachelor's and then my PhD, all of them in computer science and AI. And I actually worked on human-robot interaction and this particular field called AI planning within artificial intelligence. In 2014, I finished my PhD and I went to work at IBM Research as a research scientist. And I've been there ever since for about 7 years now. We work on mostly applying the latest and greatest in AI, which has grown over the years to encompass all kinds of things: machine learning, deep learning, natural language processing. We'll talk about a lot of those buzzwords as they were. So my job is basically to take all this latest and greatest technology and try to apply that mostly to enterprise domains. So what that means is finance, banking, airlines, anything that you do on the internet that makes money for somebody else. So that's me in a nutshell.
Gosh, that's amazing. So what I like about this is accidentally we've got somebody who works in research and somebody who works in
practical
sort of like
applications,
retail industry. Yeah, exactly. So I think we should get a lot of fun stuff out of the way. So Shivam has actually 30 minutes before the recording, he sent me a mail saying that since you guys said Simblified do a lot of research, and I do not know whether he was being sarcastic when he said that. I made this, and Shriketh, this is especially for you, I made this loose by non-corporate standards presentation.
Oh.
Shivam has put together a 30-slide presentation, not a 30-slide, but 9-slide presentation. Basically, I told him that here are the broad topics that we want to cover, like the evolution of AI, the ethics and all that. And he's actually, he took that as a brief and he's made a 9-slide presentation, which I think, if nothing else, we should upload onto Google Drive or something and link out for the episode.
Amazing.
We should just link out this episode, if nothing else. I can't say that we've ever had a presentation on Simplified before.
I was just going to say that you can tell who is a good corporate employee from this.
Fascinating.
Well, I'm trying to get into research, so is that bad for research?
No. PPTs are never a bad idea.
Well, let me put it this way. So Shriketh and I have spent our lives using PowerPoint for absolute gas. When I saw your presentation, the thing that stood out to me the most was the amount of information per square centimeter, inch to you NRIs, that's there in each slide. For us, we are like, if we had a 9-slide presentation, it would roughly be like about there wouldn't be too much information there. Is what we're trying to say.
If you're using font size less than 36 at some point of time, you're doing it wrong.
You're doing it wrong, by advertising standards in any case. All right, I think Yeah.
I think the flip side of this is something that everyone who works in AI knows very well, which is inundate your customer with a lot of data, and then they don't really know what they're looking for beyond that.
Exactly.
In advertising context, this is called, if you can't dazzle with brilliance, baffle with bullshit.
Okay. Let's start from the very beginning, guys. Like, I think a good way to start is like, how did AI? I know right now is something. I mean, over the last couple of years is when AI has been spoken about a lot, and we are seeing it in headlines, and is part of popular consciousness and all that. But where in your minds did all this really start? I'm guessing philosophically, AI must have been spoken of centuries back, and technology actually started somewhere in this, I don't know, 50s, 60s, 70s or something. So. Why don't you, since you guys are the pros working in this, why don't you give us a lowdown on that?
Yeah, I think Shivam's put it very nicely in that presentation that hopefully we'll be linking to. But roughly what happened was there was a whole bunch of scientists, and remember, this is, as with computer science as a discipline, a lot of this comes from a mathematics and science and engineering kind of background. So there were a lot of people in the 40s and the 50s, especially after World War II, when you had these huge computing advances, huge for that time, right? You had these big computers that came out and so on. People naturally started thinking about this question of, can computers think? Can they actually, do what we associate humans with? And a lot of this history actually goes back also to Alan Turing, who did a lot of pioneering work back in World War II. So he used to obviously work at Bletchley Park for the British code breakers. They famously broke the Enigma machine and all of that. But then Turing, even before that, he'd been doing a lot of theoretical work on this notion of can a machine think? And so there is this famous phrase, the Turing Test, which gets thrown around quite a bit. And really, Turing's test was a very simple test where he basically said, if you put a computer and a human behind a curtain, right, in a dark room behind a curtain, and then you had another human sit in front of it, could the computer fool that human that it was actually a human for some X percentage of the time, right? And so that's another way of putting this thing of, can computers think? So as with all sciences, I think a bunch of researchers got together and they started trying to formalize this. And I think, Shivam, you can pick up some of the story, right, with the Dartmouth, colloquium that happened in the 50s. I think you put that on your slides as well, right? So there were a whole bunch of researchers, most of them in North America at that point, who came together at the Dartmouth University in Hanover, New Hampshire. And this was, I think, summer of 56. So John McCarthy was one of these computer scientists. There are a whole bunch of people from the east coast of the US and the west coast of the US and so on. And basically these guys put themselves into a room for about a week to basically debate this question of, can a computer think and what does it mean for a computer to think? And remember, at the same time, when this was happening, in the 30s, there was this whole coining of the word robot, right, from this Czech book and, the robota for the workers and so on. So in some sense, it was almost a parallel development of, the physical manifestation of what we think of AI, at least before machine learning became big, which was robots and, all of these automated beings and so forth, along with the question of what goes into the AI. So can a computer think and so on. So that's kind of a little bit about the history of where it started off. I don't know if Shivam wants to add something to that.
Yeah, one of the things I would like to add here is even if like Alan Turing proposed the imitation game back in 1950s, most of it was left undone because of the sheer advancements of computing capabilities were not available at that time. Like back in 1970s and 1980s, it really started to pick up, as Kartik said, when the funding got available and everything. So Moore's law and computing capabilities with the AI advancements go hand in hand. Somewhat one of the great examples of this is back in 1997, the Deep Blue was able to defeat Garry Kasparov for the chess game. And just like few months ago, Chinese Go champion was defeated by Google's AlphaGo, which are like pretty close to each other, which tells how much computing capability is important even for AI.
It's actually interesting that you should bring up these advances because, I was going to talk also about AI as a discipline. And I think this is true of all sciences, but since AI has had such a short lifetime. If you think of the pure sciences like physics, history, they have longer histories, right? So it's hard for us to comprehend in our lifetimes what has happened, right? Whereas with AI, because of this compressed timeline of really it started in the 50s, right? And so it's been what, 70 years, 80 years at the most, right? One thing that we are all, you can observe really well is there are these boom and bust cycles, right? Boom and bust cycles. And a lot of that, it has to do with two main things, as Shivam points out. One of them is funding, and then the other one is compute, just sheer compute power, right? And actually, there's a phrase which I need to knock on wood thrice before I say it. There's a famous phrase called the AI winter, and so the concept of an AI winter is basically think of it as the hype cycle, right? So basically, AI reaches the peak of the hype cycle. It promises everything plus world peace at the end of it, right? And then the hype cycle kind of bursts, and then everybody goes cold on AI for a point, and then it goes in those, boom and bust kind of cycles. And I think the way AI has made progress over the past 80 years is exactly with these sort of very groundbreaking, very groundbreaking systems that come out once every 20 years, once every 30 years. It's actually interesting. Shivam mentioned Deep Blue. I work at IBM. I work at IBM Research, and Deep Blue actually came out of IBM Research in the 90s. And in fact, here's a shout out to the person who hired me at IBM Research, my first manager, Murray Campbell. So Murray was actually part of the team on Deep Blue. So he was a graduate student in the 80s in CMU. So there were three of them at CMU who really liked chess, and so they were working at the intersection of chess and computing, and at that time, high performance systems and AI. And all of them brought that expertise to industry, to IBM, where IBM basically put together the resources and the compute scale required to build a system like this. So a lot of the videos that you see of Deep Blue, including the famous match where it defeats Kasparov and all of that happened, that actually happened in the auditorium at IBM in Yorktown Heights. But then, like I said, different companies at different times in the development of AI tend to take that baton. So more recently, it's been Google and DeepMind and so on, where they did this with AlphaGo, first with the Go game, and then, they've been doing this for all sorts of other games now, computer games. They're trying to extend this to medicine, to a lot of other fields as well. But that's really the story of AI. Like it mirrors, in many ways, the story of new nations in some sense, if you think about it. It's about sort of the enterprise and the Wild West kind of mentality, and it goes in these boom and bust cycles.
That's fascinating. I have one question though over here. Is so another technology that kind of evolved at around that same time, I guess in the 60s and 70s, was the internet itself, which started off as a research project with the US military's DARPA team, and what ended up being very similar, right? What ended up being a hobby and a tool for researchers and usually university laboratories to communicate with each other. Again, East Coast, West Coast suddenly ended up being a lot more than that. Before you knew it, you had email, and then before you knew it, you had cat GIFs all over the internet. Again, GIFs, sorry, since you are in the US.
And you had Orkut. Don't leave out Orkut.
And you had Orkut. Yes, important. These are the milestones in the internet. So the question that I really want to ask is, like, when you were saying all this, so it's obvious that AI would improve, enhance, find more use cases, etc., with the increase in computing. But did the evolution of the internet and interconnectedness in any way help AI as well, apart from the fact that researchers could talk to each other and access information online more easily?
I think internet did help AI in a way that everything became accessible to the consumers. For example, we all have mobile devices right now. The most basic thing which AI needs is data. For any algorithm to learn, they need data. So I think with internet, more data became available for the models and algorithms to learn. So I think that was the biggest breakthrough or game changer.
Right. Yeah, I agree with that, but I'll also qualify that a little bit. I think the internet certainly has helped in the latest sort of boom cycle, right, in some sense, right? So really when machine learning and AI started being talked about in the same breath and they started being intertwined, right? And now, of course, we take it for granted that, as I think Sundar Pichai said, data is the new oil, right? So we take it for granted that data is the basis of a lot of these advancements that we have come to take for granted. But there was a time, so this, let's say the 1990s, because the internet really, took off in the 90s and the 2000s and so forth. So I think, Chuck, to your point, there definitely was a time when these two technologies were sort of developing in parallel, right? And people didn't really see the potential to apply one to the other, right? Yeah, and this also, going back to something I said, this has a lot to do with the fact that AI in the 70s, 80s, 90s, it was more about embodiment, right? So it was more about AI is in this robot and, AI is manifested as this particular thing. And I think the big difference that has happened in the modern era, like, starting from, let's say, 95 onwards to where we are now, is the embodiments have either become much smaller, so like your cell phone that Shivam was referring to, or they've disappeared altogether. Right? AI is just in the cloud. It's there. It's a big brain somewhere. Big data. It's processing all of this stuff. So I think that's what has changed, because the internet has now made it possible for AI to really exist in every nook and corner of our lives. Right? Whereas I think earlier on, that wasn't quite the case. Like if you wanted to see AI in action, you would have to go to some warehouse or to some, academic lab somewhere and look at a robot. So, yeah.
Yeah, I would like to add a point is I think pretty much everyone agrees that for a capitalist society and corporate hungry companies, revenue is pretty important. And we know that to generate revenues, the company kind of realized that through AI, generating revenue is pretty much crucial, because through AI, you can personalize things for everyone. I would like to call back those Windows 95 days where you would see a Netscape or Yahoo.com page and those news articles. Those news articles would be the same for everyone at that time. Like if you are in India or if you're in Mumbai, same articles and news would be showed for you. It was by locality, but not by your personal taste. So I think the personalization also became a big thing in terms of giving consumers a taste of what things they like. And I think it began back in 90s, where it eventually realized into the real potential of AI being used to generate revenue.
I have to add one thing here. I read a book some years, maybe a year or two ago, called A Man Who Solved the Market or something. So this is about a guy named Jim Simon who used mathematical models and computers and what you might call machine learning to predict stock market trades and made $1 gazillion. And what they did at that point of time, because data was not available, they actually, I think this was in the 90s or 80s, probably 90s. They had people actually, feeding stock prices manually into computers, compiling huge data sets as possible, making the, computer churn, sort of consume everything, spot correlations, and basically teach itself. So that's what they did. And well, one interesting fallout of that is one of Jim Simon's colleagues was this guy named Robert Mercer, who was instrumental in getting our greatest president ever, Donald Trump, into power. So, yeah, AI can be responsible for that kind of thing.
when you said that, Naren, about how people used AI in some sense in the 90s in this purpose, I was remembering an article I read really recently. Some companies that try to predict which stocks are going to do well and all that. I forget exactly which player in the entire cycle does this. Shriket will probably know. They use satellite imagery to figure out how busy certain ports are. They also use satellite imagery to see, to check other things, like, for example, whether Walmart has enough people coming to it, for instance, so they know to buy or sell shares. And it's very interesting how these technologies, of course, AI is the layer that makes all this happen, but it's very interesting how it's gone from the application that you were talking about in the 90s to satellite data and all that right now, which I guess any of us could actually do if we had the time and inclination to do. I just wanted to mention that randomly.
Yeah, no, I actually, well, couple of things. One, I want to say, Naren, what are you doing reading books? We want you to write the book. But actually, so one way to look at this also is what AI has given us is the ability, and again, it's not special in this, right? I think even back in the 40s and the 50s, what computers were being used for really is computations that are far too great in number, or in complexity for humans to do, right? That's what they were doing when they were doing code breaking, when they were calculating missile trajectories, all of these things, right? But what now the additional AI layer, as you call it, Chuck, has done, right, is it's allowed us to mine correlations, right? And to say which of these correlations that you're seeing in data, right, are really approximators for causation, right? Because that is the fundamental question sometimes, right? And I think it's the fundamental question that runs a lot of things, which is we see a lot of correlations every day in our life, right? And if you have enough data and you process it at a high enough volume and at a high enough scale, you'll see these correlations everywhere. But then the real important thing then, right, is which of these are ready to make the jump to causation, right? And that underlies everything from clicking on ads to buying products to, recommending personalized articles to people. Any application of machine learning and AI that you can think of, right? It's really about this thing of, is this thing just a fleeting correlation, or is this a causation that I can get this guy now to pay big bucks, to buy into this causation, right? So, and of course, there's a whole very interesting sub area of AI, called causality, and there are these structures called Bayesian networks and so on, which are basically there to model these kinds of things, right? And I think they're kind of, in their own way, they're coming back into the limelight now because we've done everything we can with rudimentary, statistical processing and rudimentary data processing, data mining, data science. And now we want to go to the next step, which is what we as humans do as well, right? You see 2, 3, 4, 5 examples of something, and then you build a hypothesis, and then you build that, causality of, when I see A, B tends to happen, right? And I think that's where AI systems really are trying to go now in this brave new world.
That's
Even with the
other thing is, I think also in the field of AI, it's not even apparent to humans what really the correlation or what it is, but the AI says so. That's what was there in that Jim Simons book. So he would literally, the computer would find a correlation between potato prices and, let's say, IBM stock, and they found that they are correlated in a particular way. So all he needed to do is find out what way the potato prices were moving, and he could take bets on the IBM stock and make a lot of money. So, yeah.
I'm reminded of the Silicon Valley scene, Shrikant. I'm sure you remember this. Remember that cicadas and sesame cicadas and sesame seeds were scene. But again, I don't think AI was involved. I think it was just a mad genius who.
The more real. The more in reality famous equation was Eduardo Saverin betting on oil futures and making $300,000, which he eventually invested in Facebook. The initial seed fund of Facebook, yeah.
Shivam, you were saying something before we.
I forgot.
That's okay.
I was saying that apart from like causation, a lot of mathematics is changing now because with the emergence of quantum computing, with the current conventional computing, we are only talking in ones and zeros on the hardware level. But with the quantum computing, the probability can exist in various forms, in various states, which is totally a new way to look at AI. And that is also a current area of research, which I don't know much about, but it is a lot of challenging and still have a lot to progress.
And now a little break, and we will be right back with a conversation on AI and all its myriad different things with Kartik and Shivam right after this.
Have you ever wondered where the business world is headed? How the ways in which we create, market and sell to consumers will evolve? Or if we'll ever go back to wearing pants while working? For answers to all of this and more, tune into Advertising is Dead with me, Varun Dugirala. Every Tuesday, as I talk to entrepreneurs, leaders and change makers from across business, media, marketing and beyond. You can catch all episodes of Advertising is Dead on the IBM Podcast website, app or wherever you get your podcasts from.
And welcome back, and let's get back to our interview. Okay, so I just want to add on to what Shivam just said right now. So we might be jumping ahead in the conversation over here, but that's completely fine. One of the books that I'm reading right now is this book called Exponential. It's by a statistician. I guess, called Azim Azhar. And the basic premise of the book is like technologies have, well, you can guess what it is, right? It's so much has happened in the last few years and is growing at an exponential pace. It, of course, starts with the premise that humans are extremely, extremely bad at recognizing compound interest or compounding, the powers of compounding, even if it slaps you in the face. And talks about how technologies and things that were dismissed at, laughed at, etc., just a short while back, right? Just say 25 years back. If you go, like just yesterday, I was watching this interview with David Letterman interviewing Bill Gates on his show in 1995. And Letterman starts with, so tell me about this thing called the internet. And he is extremely ludicrous about the entire thing. And Bill is doing his best to like, okay, must not lose my cool. This idiot can't see what's happening.
Back in 95 when Bill Gates didn't know.
Fair enough. And I remember also seeing other interviews with Jeff Bezos, for instance. Fortune was interviewing Jeff Bezos saying, so are you saying people actually want to buy books using this thing called the internet? And to be fair, Bill Gates did a very bad job of describing what the power of the internet could be. I mean, it's very obvious to us right now. Whatever he was saying, you could connect with each other and all that. Guess he didn't do a very good job of explaining. But anyway, the point of that book essentially is this, right? One, technology is going to increase at a rapid rate for all the things that you guys said, and especially that Shivam said in his presentation. It's like Moore's law, all these things coming in together. So everything's going to change exponentially. But it's not just the fact that computers are going to get faster and you'll be able to do X things, say half time quicker or quarter time quicker, but it's also about the new things that can be added on top of that. As a result of having this new computing power, there is so much more that you can do, new spaces that can come in. In fact, there's this lovely line in Silicon Valley folklore. I don't know if it's apocryphal or not. It talks about the constant dance that Intel and Microsoft had. Like whenever Intel would improve their chip quality, Microsoft would find a way to use that extra power. So this is line, what Andy giveth, Bill taketh away. Andy being Andy Grove of Intel at the time. This is fascinating. So the entire book's premise is this, that technology and AI, led by AI, has reached such a stage right now that is starting to subsume other parts of the world, right? It started off with, say, all the computing things and all that, but now it's getting into, for example, stockbroking or deciding what entertainment that we're doing. The application of AI into things like healthcare and all that is going to be even more, and we can't see it. And that's the other point. No matter, even though we know we are in this exponential curve, we have no way of even imagining what life is going to be in a few years' time. And let's not even talk about Web3 and all that, because that's the intersection of AI and Web3, I think, is another conversation completely together. But yeah, I just wanted to mention that because I just remembered it when I saw Shivam's presentation with Moore's law written out there in great detail. Sorry for the deviation.
I think that's an important point that Shivam also made about quantum, right? Because that's exactly this whole point
exactly
of
this,
exponential increase and all of that, which is, with the exponential increase, you just know that you're going to hit the physical limitations, of Moore's law. And then, but AI is still hungry, right? You still need compute, you still need more processing power, and then you have to change something fundamental, and that's something fundamental people are betting is going to be quantum, right? So now, instead of having one state at the end of a bunch of processing, you can have a bunch of quantum entangled states, right? And this is also something, by the way, that, I think right now the leaders in this space are, Google and IBM have been sort of alternately releasing larger and larger qubits of processing on our quantum computers and our quantum devices and so on. This is the future. I think how people harness quantum computing as a substrate on which to build more efficient, more powerful, larger AI and ML systems, I think that's eventually going to determine in the next 10 to 20 years even, where where technology goes, what direction it goes in.
Yeah. 40 years of Moore's law, and I'm very disappointed nobody's actually said we want Moore or something of that sort. It's
Ye dil mange more.
Ye dil mange Moore is the Pepsi Intel collab nobody asked for. But let's I think we are still on that first question of evolution of AI, and obviously I think we can go. I think we can end up talking about that for us. But so I like, what's the basic difference between artificial intelligence, machine learning, deep learning, and if you want quantum computing as well? I think this is something that's not very clear in my head, and I think you guys would do a great job of clearing it all up.
So I can go, and then Shivam, feel free to jump in, correct me if you think I'm saying something that's absolute bullshit. But I think some of it is really just I would say it's a historical vestige, it's a historical difference in some sense, right? So AI, artificial intelligence, is the more general term, it's the more all-encompassing term, starting from the 50s and the Dartmouth conference and everything that we talked about. Now, what happened in, I'm going to say the mid-80s to the late 80s, was this notion of machine learning was something that started being coined. So this was actually someone, one of the researchers who was doing this was Pat Langley at the University of California in Irvine. I've actually had the fortune of working with Pat and, interacting with him and so on. But what essentially happened at that time was people were tired of this notion of AI as just a set of rules, right? So this was the time of the expert systems, right? These large, think of them really as large decision trees in some sense, right? And so really at that time what AI was a whole bunch of rules that people would stuff into a computer, right? And they would prime the computer for all kinds of scenarios. So if you see this, do this. But if you see this and this other thing and not this thing, then do that, right? So think of it really as, a more sophisticated form of Boolean logic, right? Where you just have a bunch of gates and you're telling the computer, not Bill Gates, a bunch of Boolean gates where you're telling the computer, if you see these conditions and not these conditions, do this thing, right? And people got tired of that because they said, okay, there's a lot of corner cases that the computer is not able to deal with and all of that, right? And that's really, and in fact, that is when the previous AI winter happened, right? It was this whole craze for expert systems, and people were spending, in the 80s dollars, atrocious amounts of money. They were just throwing them at AI. Like from what I hear from colleagues who were around at that time and advisors and so on, apparently AI was the hot thing. Like even like the position we're in now is dwarfed by that time. Like people had lavish AI. This was the mid-80s, and then there was a huge slump, a huge crash, which is what a lot of like researchers and a lot of people who make their bread and butter from AI, they are afraid of even now, right?
It was like the internet.com boom of the 2000s, right?
Exactly,
so something like that. Wow, I never knew there was an AI boom and bust.
Well, there's an AI bubble too. That's the whole, the AI winters follow AI bubble. And so I think machine learning really arose as a reaction to that. Once that crash happened, right, in the late 80s and the early 90s, machine learning as a discipline came out of that, and that's when you had this combination, some would say unholy nexus, depending on where you are. You had this combination of statisticians, right? So you had, people who are well versed in statistics coming in and saying, hey, we can tell you how to deal with all this data and look for patterns and correlations and clean the data and all that stuff, right? And you had all of these AI experts and computing experts who came in and said, okay, I'll basically rebrand everything that you had, created in statistics and give it a sexy name, and then it's machine learning suddenly, right? And so that's where this whole field of data science was born, right? And then just to round it out, right, because you also talked about deep learning, right? So deep learning is a more interesting, case. So deep learning has been around for quite a while. I think a lot of people don't realize because, they hear about deep learning now in the 2010s and the 2020s, but deep learning has a very rich history from at least the 70s, maybe the 80s, right? So one of the first deep learning systems was this thing called the Perceptron, right? So the Perceptron was basically an AI that was built in the 70s, and as its name suggests, it was basically this huge network whose job was to perceive. Its job was basically, you give it an image, and it's trying to perceive what is in that image. Like, what does this image represent? Are there objects in this image? Basically Google Lens, but 50 years ago, right? In the 70s. And then the Perceptron was basically this first experiment in saying that we can basically have a bunch of inputs and we can connect them using this network architecture, and we can try to make, grand theories out of these things, right? And then that's kind of what developed, and it's really, the reason it's called deep learning, right, is people started stacking these network layers one on top of the other, right? So think of it as, instead of the rules that everybody started hating that were in the expert system, you now started stacking these generalizable architectures, these layers, right? And the layers were supposed to learn on their own in some sense, right? So it's like exposing a baby to a whole bunch of, situations and then asking that the baby learn something. So that's really what deep learning is. So deep learning builds on top of machine learning, but it's really a very specific sub-discipline of, machine learning and AI. That focuses on these, stacked up layers and stacked up networks in order to either, look at pictures and tell if there's a cat in it or do more productive things. So.
Wow, that's fantastic. When I Googled a Perceptron, the first result that I got was from a site called Towards Data Science, whose headline is, "What the hell is Perceptron?" Not exactly the...
Yeah. And I think one of the things I think with AI is, you're deep in the hype cycle when people think that the technology was invented yesterday, and that's actually not true. So,
wow. Yeah, that's deep. That's deep. It's another way.
It's kind of the same.
Yeah.
It's kind of the same thing where like a comedian becomes famous and people are like, he's new, but he has been struggling since last 5 or 10 years. Something like that.
Wow, that's a very interesting way of looking at it. So there's that line, right? It took me 20 years to become an overnight success. So it's something like that over here, I guess, is what you're saying, Shiva?
Yeah.
Yeah.
Or the way that my PhD advisor puts it, I was doing AI when there was no money in it.
Wow, that's yeah. All right. Shivam, anything you want to add to that entire thing, AI versus ML, especially from like a in practice point of view, since you've been working on the Kartik gave us the theoretical side of it in some sense, the research side of it, but since you've been working in industry, how are these things looked at differently?
I would say that in terms of business organizations, these things are pretty much hyped, and a lot of potential goes how much company wants to leverage their capital in this kind of new technologies. Mm-hmm. Just to add one little detail about what Kartik was saying before, the Perceptron loosely follows the concept of having a neuron in a human brain. So what happens is, if you have a bunch of neurons, they connect with each other, and that's how it will learn information. And when this neurons, when a lot of neurons connect, they create layers, and you can architect how many layers you want to have, and that's why it's called deep learning, as he said, because it has a lot of layers. And deep learning is a really big hype in the industry right now, in business, in short.
And why is that hype? So why? No, go on. There are many questions I want to ask.
No, I was just going to say, when Shivam was saying his thing about when neurons connect to each other, that's when the magic happens. I was thinking in my head, neural networks are really like the Minesur Mera Tumhara of AI. It's like, it fights like once and creates magic. But yeah.
I have something to add about this. I don't know if this is true. I remember reading about this a few years ago. So an earthworm, okay, it has 324 neurons which function as its brain. So people in AI decided to model an earthworm, and they hooked up 324 nodes together and made and for the life of them they could not make it do what an earthworm would have done. So is there something that is still being missed?
I was going to say most likely what the 324 things that the AI people hooked up ended up doing is probably classifying cats on the internet, because that's what all AI systems do in the end. But no, actually, Naren, to answer your question, yes, I think the difference probably, right, there's one of two areas where the difference may have been, right? One is in terms of the data and the circumstances that things are exposed to, right? Because it's not enough to just model or mimic the architecture of some system, right? Tomorrow, let's say, today it was earthworm, but tomorrow, let's say you want to do this for a human brain, even if that is possible, let's say 50 years from now, 100 years from now, right? you also have to immerse it in the same sort of sensory context and in the same, with the same input that all of us see from the moment we're born, right? And that is an extremely hard task, right? That's really what everybody who's working on AI machine learning has been trying very unsuccessfully to do. Like the reason they need all your data, the reason they need to capture every movement on your phone and everything you do on your computer and every website you browse is where, in the end, we're trying to capture a very poor representation, right, of what it is we're actually seeing with our own sensors, with our eyes and hearing with our ears and so on, right? So that's one part of the answer, which is, the data that it was exposed to may not have been the same. The second thing is a little more involved. It's a little bit about the architecture itself, right? It's not enough to just throw a neuron in there and connect a bunch of neurons, right? So this is something that's really exciting. This is something that a lot of research has happened in the past 5 years. Like this is something you can actually say is hot off the press, cutting edge, state of the art, which is in AI now, there is this realization that we have all these different kinds of neurons, right? We have all these different kinds of activation units, for lack of a better word. And then we have different ways to connect these things up. So there are different network architectures, right? And really all these things that what they're trying to do ultimately is model something like the human brain, right? Because, I mean, look, let's face it, we could talk for 10 podcasts on how the human brain works and still not figure it out, right? Like the world's best neuroscientists have not figured this out, right? But that doesn't stop those of us in AI and ML from trying to make poor approximations already of what the brain does, right? But that's, I think, the really exciting part of where AI and machine learning are going in the future, which is for these different kinds of generalized architectures, right? So it's not like there's one kind of brain, right? We all have different kinds of brains and things are wired in in different ways and all of that. So it'll be exciting to see if we can have different generalized AI architectures as well, right? And maybe some architectures are better suited to tasks like vision, right? Trying to compute what is on the screen, what is going on. Maybe some of them are better suited to things like high frequency trading, right? So volume and scale and things like that. So all these kinds of things. I think that's really the answer to that earthworm thing,
Yeah. And it's that's when you realize how orders of complexity, just one order of complexity more and the whole problem goes to a completely different level. And what you can solve at one level, a completely insoluble at another. So you have to find different ways of, even getting close to it.
Yeah.
It's like it's like solving a question paper where even the questions are not known to you. So
every time I read or listen or talk about AI, my respect for the human brain and what nature has managed to do just increases manyfold. And I'm guessing this is true for you guys as well. Like you're trying so hard in some sense to replicate the human brain or to just understand it a little better. And you have to go through all these fancy systems and all that, which Mother Nature has solved out in the short matter of a few billion years, yes, but here we go.
No, I think that's absolutely true because I like one of the things that pushed me into AI, right? The reason that I got interested in this is because I think AI sits right at the intersection of, at least I personally think, the two most important questions, for humanity, right? One is, what are we, right? Like, what is the nature of thought? What is the nature of consciousness?
Yeah.
Like, what makes us human? Why do we have this thing of introspection and thinking and projecting outward and all of that, right? So that's one, like, what are we and, how did we get there and all of that, right? And the second question, obviously, is, where are we? Like, where in the universe are we? Where is our place? How did we evolve to this? Where are we going in the future? All of that, right? And it's great because AI sits really at the crux of these two things, right? It's about as close as you can get to it without actually dissecting human bodies, right? Which is why I have great respect for neuroscientists, right? Because they actually do the real thing. But this is about as far as you can go if you're lazy and you don't want to do the real thing, right? And so, really, what is the nature of human thought? That's what Alan Turing was saying when he devised the imitation game, and he said, what does it mean to actually think? What does it mean to be human-like? What does it mean to exhibit human behavior, right? And then the other thing that's fascinating, obviously, is now that we have all these space missions and deep space missions, and we're trying to understand the nature of the universe, we also have to understand that AI plays a big role in this, right? Because, NASA, for example, I have a whole bunch of colleagues at NASA who are AI scientists, who are machine learning scientists, right? And you have to put AI on some of these things because some of these are outside the scale and scope of human lifetimes, right? Like you send things off to, you send things off light years away, or even you send something to Mars, right? You can't remote control that thing anymore, right? It's a 10 going there and coming back, right? And so you have to imbue it with some intelligence of its own. So I think those are some of the real fascinating questions. Sometimes it gets lost in the road of our daily life, right? I'm sure Shivam can also concur on that, right? We go to our jobs, we do our jobs, we do these things. But these are the larger picture questions that really motivate us to, continue along these.
Shivam, no, really keen on getting your perspective on that because in some sense you are applying this on a day-to-day basis, right? Practically at work. Has this thought ever crossed your mind as you're applying, in some sense, ready AI for business purposes?
So I think personally for me, the most influential time for me when I was using AI was when I was working in healthcare because I could really see that the code which I type or the models which I train can actually save someone's life. So I've worked in those kind of projects which I was working on had a lot of talks, not just about like AI itself, but what kind of AI we are going to use, how much ethical it should be, like there should not be any bias or anything. We should make sure that we are as transparent as possible when you are handing over your models to a doctor or a hospital. You should tell them like, hey, if this guy has a fever, then these are like top 10 things like his weight or like his comorbidities or something in his past or his body temperature, something like that. So I think AI is, I'm not sure how to say this, but I think my curiosity on what ways AI can be used drives me and where the AI is heading right now. Coming back to the point where you were saying how AI is getting used in business. So as Kartik was saying, there are like bubbles and waves going for the artificial intelligence. In the current wave, the two most famous terms are machine learning and deep learning. Machine learning is sort of easier to implement and deploy and has quicker timeline compared to deep learning. So I think most of the companies or corporate companies in America, at least, are going deep into the machine learning stuff, and then the talent is sort of harder compared to any other field to hire for machine learning, and much harder to hire for deep learning or computer vision. So that's also an aspect. Another thing I would like to say here is more of the companies in different industries are working on AI, not just machine learning, like anything. The statistical analysis, machine learning, deep learning, anything. These companies are trying to establish themselves as center of excellence of this particular AI thing which they do. For example, some healthcare companies are trying to establish themselves as, yes, we are the companies which are center of excellence for hospital administration through AI. Or like Tesla is doing computer vision or self-driving through AI. Are they going to sell their technology? We don't know. But in short, like they're trying to establish themselves as leaders. So I think that's also a really big transformation happening right now in the world, where companies are now trying to establish themselves as AI leaders more than anything else.
And at this point of time, we are going to call a close to the first part of this two-part interview that we have done with Kartik and Shivam. Lots to explore over there. We hope you enjoyed this. A few links, etc., including Shivam's PPT, are mentioned in the show notes of this episode. And next week, we'll explore even more aspects, including the ethical aspects of AI, careers, and dare I say we touch upon philosophy a little bit as well. So look forward to that next week on Simblified. Till then, thanks for listening. And yeah, as Naren would say, actually, let me not take Naren's thunder away. He will say his usual outro in the next episode. So bye.
Hey everybody, it's been another great week on the IVM Podcast Network. On Cyrus Says, good friend of the show, good friend of Cyrus and myself, Mangalam Mallu is on. He's the assistant editor and anchor at CNBC TV 18, and he and Cyrus discuss how the budget of 2022 affects us all. On This Round is on me. We flipped the script as Gauri is a guest on her own show. Check it out as Kavita Rajwade, my co-founder at IVM Podcast, hosts this very special episode. On Misconduct, Raghavi and Nisha are joined by Priya Mirza. She's the host of the Longest Constitution podcast. They take a close look at the former Prime Minister of India, Indira Gandhi. On Audio Gyan, Kedar talks to Dr. Simin Patel. She's the co-founder of the Bombay Wala Historical Works. She talks about how she picks out the most interesting stories to showcase. And on Tere Mere Raste, Keshav tells us the amazing transformation of the ravaged land of Purnapani. Do follow us on social media. We're IVM Podcast on Twitter, Facebook, Instagram, and LinkedIn. Also, please do tell a friend. It really does help us when you spread the word about our podcast. And I'd also like to ask you if you could rate or recommend wherever you listen to our podcast. And speaking of where you listen to this show, if you're on an Android phone, do check out our new Android app. We have a brand new app with a brand new listening experience. Definitely check it out. I think you will enjoy it. And finally, we'd like to thank our sponsors this week, Bank of Baroda and CoinSwitch Kuber. Thank you so much for making this possible.
If you're a cricket fan, check out Edges and Sledges, India's favorite cricket podcast.
The podcast focuses on Indian cricket, the IPL, and has a ton of banter both on and off the field.
We talk about the week's biggest cricket stories with current and ex-international cricketers, coaches, or sometimes just between us.
And it's hosted by me, DJ,
me, Varun,
and me, Ashwin.
New episodes release every week.
You can catch us on the IVM Podcast's website, app,
or wherever you get your podcasts from.
Check out the Edges and Sledges Cricket Podcast.